In this video, we'll talk about the first kind of electrophilic aromatic substitution reaction that we'll cover in our class. We'll cover a handful of different EAS reactions. But let's first go over the general scheme for an electrophilic aromatic substitution reaction. So this is a substitution reaction on an aromatic ring. We're working with the benzene ring. Now each carbon in the benzene ring is bonded to one additional hydrogen. I'm going to highlight only one of them just to indicate that one of these hydrogens is going to be substituted for an electrophile. So we have a benzene ring or a benzene derivative, and then we add some molecule that has an electrophile. We'll highlight that electrophile in pink here. So the electrophile essentially replaces that hydrogen. So then our product, we have the benzene ring, and instead of a hydrogen bonded to a certain carbon, that electrophile is bonded. And remember, an electrophile is something that really likes electrons. So something that is not electron dense, it's electron deficient, that would be considered an electrophile. So generally for an EAS reaction, a hydrogen is substituted by the electrophile. And that's why it's called electrophilic aromatic substitution. I have a few notes down here. So all electrophilic aromatic substitution reactions follow a similar scheme, and they have similar mechanisms, but there are differences which we'll discuss. And we are going to discuss 5 different types of EAS reaction, electrophilic aromatic substitution reactions. All of these different types, they'll all have their own video. Each one requires different reagents. And that's how we get the different types of mechanisms and different types of products. Some of these require a catalyst. Now, I have a reminder here, just to remind ourselves what a catalyst is, what it's used for. It is a substance that helps the reaction move forward, and it does this by lowering the activation energy for the rate determining step, which in turn increases the reaction rate. So catalysts help the reaction move forward, but they are not chemically altered by the reaction. They are not chemically involved in the reaction. So you always end up at the end of the reaction with the catalyst that you started with. And then that can be reused in a subsequent mechanism.